In this video, we are going to learn how to solve basic problems involving current, electricity in physics. Right, so let's begin by knowing what current or electricity is in physics. So current is basically the flow of charges with respect to time. So we have current, which is denoted as I equals flow of charges with respect to time. So this charge, also known as quantity of electricity, is measured in coulombs and the time is measured in seconds. Now the unit of current is ampere, so this is the short form for it. Now the next thing we have to take note of is Ohm's law, the relationship between voltage, current and resistance. So Ohm's law states that a current passing through a metallic conductor is directly proportional to its voltage or potential difference, provided that temperature is constant. So we have it to be expressed mathematically as voltage equals current times resistance, where the voltage is measured in volts, right? The resistance is measured in ohms. The short form for it is this symbol, right? And the current is measured in ampere. Okay, now let's take note of the relationship between power, current and voltage. So the relationship is expressed mathematically as power equals IV, current times voltage. Alright, and let's also take note of the relationship between power, current and resistance. So the relationship is expressed mathematically as power equals I square R. That is the square of current times resistance. Okay, so take note of these formulas. And before we look at the next thing, let's take note of the formula for power, the basic formula for it, which is power equals the rate of using of energy, which is energy used up with respect to time, and energy is work done, right, which is measured in joules, where the unit of power is watts. Alright, so take note of this formula, this one, this relationship, very important, and this basic formula for power. Alright, so let's wipe this now and look at how to calculate the total resistance or the equivalent resistance in series or in series and in parallel. Alright, let's wipe this. Okay, so resistance in series is connected in a circuit. Let me represent it diagrammatically. Right, so you have something like this. So these are battery. Okay, so you have something like this. Alright, so this is just an illustration. The diagram may not be perfect, and here we have our ammeter used to measure current. So take note of it. Ammeter is used to measure current. So these are R1, R2, R3. We have the V1, V2, V3. Right, so here you have the voltmeter, which measures potential difference or voltage. Right. Now in physics, another term for potential difference is voltage. So they both mean the same thing. See that you are saying potential difference or you are saying voltage, they mean the same thing. And voltage is the work done in carrying a unit charge from one point to another in an electric circuit. So this is the positive terminal, this is the negative terminal. Let's say this is the flow of current. So the total resistance in series or equivalent resistance in series is calculated as R equals the sum of the individual resistor R1 plus R2 plus R3. Alright, so this is the total. Whereas for resistor connected in parallel, let me draw the diagram. Alright, so you're going to have something like this. This is the terminal. Okay, so you're going to have something like this. Right, so Okay, so pardon my drawing, it might not look perfect, just an illustration. Okay, so you have something like this, and here you have your ammeter. Let me correct that. So this is our ammeter. Okay, so this is the good terminal, this is the negative terminal, and let's say this is the flow of current. Alright, current is flowing in this direction. So we have a R1, we have a R2, we have a R3. So the voltage will be somewhere here, right? So this is the typical illustration of resistance connected in parallel, right? So the equivalent resistor or the total resistance in parallel is calculated using 1 over R equals, that's the sum of the individual reciprocal resistors, right? Over R1 plus 1 over R2 plus 1 over R3. Okay, so take note of this difference. This one is for resistance in series, this one is for resistance in parallel. Alright, so having known these basic things in electricity or in current, electricity in physics, let's wipe this now, solve some problems and apply each of the formulas so I can understand it better. Okay, so let's look at this question. It says a tungsten is marked 200 volts 40 watts. What is its resistance when it is operated at the correct voltage? So in this question we have the parameters. We have our voltage to be 200 volts, we have our power to be 40 watts. We're looking for resistance, is unknown. Alright, so for us to get resistance, we're going to apply Ohm's law, which is V equals current times resistance. And we don't have current. To get current, we use the formula for power. The relationship between power, current, and voltage to get it is going to be power equals current times voltage, that's IV. So the power there is 40 equals I, the voltage there is 200. To make I the same formula, divide both sides by 200. Alright, so point here, 1 point here, 5. So our current will now be 1 over 5, is something as 0.2 ammeter. So you can now plug it in this formula. So it's going to be the voltage you see remain the same, have 200 equals current is now 0.2 times R. Alright, so to make R the formula, you divide both sides by 0.2. So our R will be 200 divided by 0.2 will give us 1000 ohms, and that will be the answer. Alright, so let's wipe this now, solve another problem. Okay, let's look at this question. It says calculate the energy developed in 10 minutes by the system above. Alright, so let's look at the parameters. This problem, we have the current I to be 1 ampere, right? So this is the current. Alright, then we also have our voltage to be 10 volts inside the circuit. Alright, and we have the resistance in parallel. So to get the total resistance in parallel is going to be 1 over R equals 1 over 5 plus 1 over 5. Alright, so which is going to give us 2 over 5. Alright, so remember 2 over 5 equals 1 over R. Because multiply, we're going to have 2R equals 5. To make out this formula, divide both sides by 2. Therefore, R will be 5/2, or when you want to put it in decimal, 5 divided by 2 will give you 2.5 or 2.5, right, ohms. So unit is in ohm. So 5/2 or 2.5 ohm, right? So that's the value of R in this circuit, right? Then for the energy we are looking for, remember power equals rate of using up energy, right? So to get our power can be calculated as power equals IV, right? So in this case we have current, we have voltage, so it will be, the current is 1 times 10, which will give us what, 10 watts. So when you plug it here, I'm going to have 10 equal energy. Let's use X to represent it about the time. In this question is 10 minutes. You convert it to seconds, that's 10 times 60. When you cross multiply everything, the energy, which is S, will be 10 times 10, which is 100, 100 times 60, which is give us 6,000 joule. That will be the answer. As simple as that. Let's wipe this now, solve another problem. Okay, so let's look at this problem. It says calculate the current in the diagram above, neglecting the internal resistance of the cell. Alright, so in this problem we have the voltage to be 4 volts. We have the resistance is in pi array, so the total resistance will be 1 over R equals 1 over 6 plus 1 over 3. Alright, so when you punch it in your calculator, you're going to have 1 over 2. Alright, so remember 1 over 2 equals 1 over R. So to get R, it will be, when you cross multiply, it will be R equals 2. Alright, 2 ohms. Now, we are looking for what? We are looking for our current. So current is unknown. So to get the current, we are going to apply Ohm's law, which is voltage equals current times resistance. So we have the voltage before. Now we have the resistance to be 2. Current is unknown, so we have 2 current. So to make current, the straight formula, we multiply by 2. So therefore, our current will be 2 cancel say 1, 2 cancel for 2. So current will be 2 ampere. So it's as simple as that. Let's wipe this now, solve another problem. Okay, so let's look at this problem. It says an electricity board transmits electrical power of 400 kilowatts through a national wind of 40 kV. Alright, calculate the current transmitted. So in this question, we have our parameters. We have the power to be 400 kilowatts. So you convert this kilowatt to watts. If you do it, you're going to multiply 400 by 1000 to give us 400,000 watts. Then we have the voltage to be 40 kV. To convert it to volts, so you multiply this 40 kV by 1000, it's going to be 40 times 1000, which will give us 40,000. And we're looking for current is unknown. So to get current, we're going to apply the relation between current, voltage, and power. So power equals IV. So which will be 400,000 equals current times the voltage is 40,000. So to get current, divide both side by 40,000. It will cancel. So therefore, current will be, when these cancel each other, we have 10. So current will be 10 ampere. Alright, so let's solve one more question before we call it a class. Let's wipe this. Okay, so let's look at this problem. It says an electric iron draws a current of 5 ampere when connected to a 250 voltage supply. Calculate the energy consumed by the ion if it is used for 10 minutes. Alright, so in this question we have a parameter, have current to be 5 ampere, we have a voltage to be 250 volts, we have time to be 10 minutes, and we are looking for energy. This is unknown. Alright, remember, to get energy can be gotten from the relationship with power equals energy used up, energy with respect to time. Alright, okay, now to get power, remember again that power is related to current and voltage, mathematically expressed as power equals IV. So to get the power, I have a current and we have a voltage, so power will now be 5 times 250, right, so which is going to give us 1250 watts. Now that we have power, let's plug it here and get energy. So it will be 1250 watts equals energy. Let's replace it with x over the time there is 10 minutes, convert it to seconds, which is 10 times 60. So you multiply the energy, x will be 1250 times 10 times 60. So if you punch it with your calculator, you're going to have 750,000 joule. If you want to leave it in kilojoule, divide this by 1000. If you do it, it will be 750 kilojoule. Alright. Oh, what I would say is 75,000 instead of 750,000. So guys, correct it by adding one more zero to that value. Okay, so guys, this is basically how you can solve problems involving basic current electricity. Alright, we looked at Ohm's law, the relationship between voltage, current, and resistance, and many other things we looked at in the course of this video. So with this, I've come to the end of the class. Hope you learned something interesting. If you are new to the channel, ensure to hit the subscribe button now to subscribe to the channel for more videos. Also like, share, and comment on this video. Tell me how you feel from what you learned from this class. If you seem to have any specific question to ask, feel free to leave your question in the comment section below, and I'll be sure to give you a response. Thanks for this class, guys. Thanks for watching.